Hello everyone. Take a look at this video. It's about the Titanic ship disaster where a number of people tragically lost their lives because the Titanic ship sank into the ocean. It's also one of the most popular machine learning projects which beginners typically do on websites like Kaggle and add this project to their resume. The technique which is used to solve this particular problem is decision trees. The problem itself is pretty simple. There are a wide range of people on this ship who belong to different ages. There are males, there are females, and not just that, there are people also belonging to different economic classes, such as there are some people who are rich and there are some people who are poor. Based on all these variables, the goal is to predict which people will survive the Titanic disaster and which people will not survive. Decision trees is one of the most important techniques in machine learning, and this playlist, which I am creating right now, it's titled Building Decision Trees from Scratch, will teach you all you need to know about decision trees. So let's get started. My name is Dr. Raj Dandekar, and I graduated from Massachusetts Institute of Technology in 2022 with a PhD in machine learning. Since then, we are on a mission to make AI accessible to all, and this playlist is a part of that mission. So, this particular playlist is going to be all about decision trees, but I am going to teach it to you the right way. First, let me motivate decision trees a bit. If you go to this website called Kaggle and search decision tree datasets, you'll see that using decision trees, you can solve a wide range of problems, such as machine failure prediction using sensor data, bank marketing shortly, predicting employee turnover, breast cancer, bank marketing campaigns data set, drugs for decision trees, employee satisfaction survey data, Amazon business research, employee attrition, hotel booking cancellation. In fact, there are huge number of other data sets also, such as I mentioned, Titanic data set, used car price prediction. A wide range of machine learning problems can be solved using decision trees. And not just for projects, even in industries, I asked ChatGPT in which industries are decision tree algorithms commonly implemented, and you will see that they are used in finance for credit scoring, fraud detection. They are used in healthcare for diagnosis, treatment, prediction of patient outcomes. They are used in marketing and sales for customer segmentation, predicting whether a customer will buy your product or not. And they are used in a wide range of other industries. In fact, I have few friends who are working in startups, and they frequently tell me that irrespective of the generative AI hype, the ML algorithms which bring revenues to their company are decision trees, random forest, and gradient boost. So I believe this is enough motivation to get curious about this playlist and start with this first video where I will give you a brief outline of what we will learn in this playlist, and we'll also cover the first lecture, which is devoted to what is decision trees. So the next question after you are interested is that how do I start learning about decision trees? What many students do is that they directly start from TensorFlow. They take the TensorFlow code which is available, and it's just 10 lines of code, and you can even get great results on projects such as the Titanic project. The problem is that through this approach, you will not learn anything about the underlying building blocks of decision trees. And there are many great building blocks, such as Gini impurity is one building block, entropy, misclassification error are other building blocks. We will learn decision trees the right way. We will build decision trees step by step. First, we will build it from scratch, and then I will also show you the hands on Python demonstration. So I'm following a channel called StatQuest, which is a brilliant channel, and it's one of the inspirations for making this lecture series. So let's get started with today's lecture. In today's lecture, our agenda is to look at a simple concept, which is what exactly are decision trees. And then towards the end of this lecture, I'll also tell you about what you can expect from this playlist and what's the agenda which we will follow. So let's look at the simplest decision tree. The decision tree starts with a statement, and then there are some decision points. The statement is, do you want to learn about decision trees? If yes, then you can continue watching the video. If no, don't watch this video. That is the simplest decision tree. And from this decision tree, you can look at the building blocks of a decision tree. There is usually a statement such as, do you want to learn about decision trees? And then there is a decision. So there is a branching into two segments. If yes, then do this action. Watch this video. If no, then don't watch this video. It's one of the most simplest and intuitive concepts in machine learning. So that's a simple decision tree. Great. But decision trees themselves come in two types. The first type of decision tree is classification tree, and the second type of decision tree is regression tree. Another mistakes many students make is that they think that decision trees are only of one type, which is the classification tree. But actually, regression problems can also be solved using decision tree. What is the difference between these two? The example which we saw before, do you want to learn about decision trees? If yes, watch this video. If no, don't watch this video. That's regarding classification into categories. So that is an example of a classification decision tree. On the other hand, in the regression decision trees, you are predicting numerical values. For example, this is just a sample which I've constructed. The statement still remains the same. Do you want to learn decision trees? Yes. Then I'm predicting that your age is between 15 to 40. If no, then I'm predicting your age is less than 15. So you can see that here also there is a statement made and there is a branching off into two. But here I'm actually predicting numerical values rather than just a yes or a no classification, right? So that's why it's an example of regression problem. In fact, all these examples on the data sets which you saw, they might be classification or regression. And decision trees are powerful techniques to solve both types of machine learning problems. So it's important for you to know this distinction between the two types of decision trees. Then let me actually demonstrate a simple classification tree which I have constructed to predict whether a patient will to predict the risk of diabetes for a particular patient. So I start with a statement if age is less than or equal to 45. So you consider a person, you look at their age. If age is less than or equal to 45, so if you go in the yes, then you check their weight. So it's a young person, you check their weight. If the weight is less than 60, it's great. There is a low risk. But if it's a young person, but its weight is greater than 60, then the person is at a moderate risk of diabetes. On the other hand, let's look at the other side of this decision tree. If my answer is no to age is less than or equal to 45, which means the person is older, that's established. Now, if the person is older, if their weight is less than or equal to 70, which means we are on this path, it means they are at a moderate risk. But if the person is older and if their weight is greater than or equal to 70, then that means the person is at a higher risk of diabetes. So this is how classification decision trees are constructed and they can be as long as possible. So this is called as the depth of a decision tree, how deep I am going with the amount of segregations which I am making. Before looking at a very nice practical example, there is some terminology which I will want to introduce so that this terminology stays with you till the end of this decision trees from scratch series. It's a pretty simple terminology, but it's important to get it right now so that you don't make mistakes later. The statement which is posed at the start, such as is age is less than or equal to 45, or in this case, do you want to learn decision trees? This is called as the root node, the statement which is posed at the start. Then all the blocks here which are shown in the blue color, they are called as internal nodes. Why? Because internal nodes have an incoming arrow and an outgoing arrow. If you look at all of these uh, blue boxes, all of them have an incoming arrow and an outgoing arrow. Look at this, it has an incoming arrow and it has an outgoing arrow. Look at this, it has an incoming arrow and it has outgoing arrow. So these ones which have some information incoming as well as outgoing are called as internal nodes or branches. And then there is the third type. Look at the blocks which are in the red color. All of them only have incoming, right? They don't have anything outgoing. Look at this block, it only has incoming. Look at this block, it only has an incoming arrow. Similarly, look at this block, it only has an incoming arrow. Look at this block, it only has an incoming arrow. Such blocks or nodes of the decision tree which only have incoming arrows are called as leaf nodes or leaves. So there are only three terminologies to remember and understand here. First is the root node, which is the top level statement. Second are the internal nodes or branches. These are nodes which have an incoming arrow as well as an outgoing arrow. And the third type of nodes are called as leaf nodes or leaves. These only have an incoming arrow. They have no outgoing arrow because this is where typically the decision tree ends. These are the three terminologies which you need to remember. Now, I will want to demonstrate a simple example of decision tree to you. And when I learnt about decision trees the very first time, I really enjoyed taking this example. So you see, decision trees like asking a bunch of questions, right? Here I asked a question: is the age of the person less than or equal to 45? If yes, great. Then is the weight less than or equal to 60? If yes, great. So there are a bunch of questions. So this is very similar to the 20 question game. So imagine that you are playing a game with your friend where you have a character in mind and your friend has 20 questions to guess the character which you have in mind. This is exactly like a decision tree. And now let me play this game with Chat GPT. So let us play the 20 question game. I have a character in mind. You have 20 questions to guess the character. Now, I will already tell all of you who are watching that the character which I have chosen is Sherlock Holmes. And let's see if within 20 questions, if ChatGPT is able to get this correct. The first question ChatGPT asks is your character from a book, movie, TV show, or a video game? Yes. Sherlock Holmes is a character from a book. Yes. The next question is your character from a book? Then I'm also going to write here that yes, it is from a book. The third question is the book your character is from part of a series? I'll say yes because there's a series of books which Arthur Conan Doyle wrote about Sherlock Holmes. Is your character from a fantasy book series? Yes. Is your character from a fantasy book series that has been adapted into a TV show or a movie? Yes, because there is both a TV show as well as a movie on Sherlock Holmes. Has the TV show or movie adaptation of your character series gained widespread popularity? Yes. Is your character from the Game of Thrones series? No. It's trying to answer. Is your character from the Witcher series? No. Is your character from the Lord of the Rings series? No. Is your character from the Harry Potter series? No. It has reached 10 questions. Is your character from the Narnia series? No. Is your character from the Wheel of Time series? No. Is your character from the King Killer Chronicle series? No. Is your character from a of Ice and Fire? No. Is your character from the Stormlight Archive series? No. Is your character from the Mistborn series? No. Is your character from the Dark Tower? No. So we are at the question number 18 now, and ChatGPT is still not able to answer it correctly. So we are at the 20 question mark, and ChatGPT is not able to get it correctly. So this now I want you to understand why this is like a decision tree. So let's look at right now from question number one how ChatGPT is making his prediction. First, it asked me whether the character is from a book, movie, or a TV show, right? So first, it asked me whether the character is from a book, movie, or TV show. If if this is yes, and if this is no. I did not know what ChatGPT had in mind if I had answered no, but since I said yes, then we go to the second question: is your character from a book? So then ChatGPT asked me the second question: is the character from a book? Then again it's divided into two: yes and no. So if it's yes, then ChatGPT asked me the question that is the character from a book a part of a series? So then is it a part of a series? So you see how a decision tree is being constructed here. And since there are 20 questions which ChatGPT will ask me, the depth of this decision tree is basically 20. So the depth of this decision tree is 20. The goal of machine learning models is to ask the correct question so that we get the correct answer. So right now we got the wrong answer, right? Because the questions were not asked correctly. So ultimately, when we are predicting, let's say, the risk of diabetes in a huge machine learning data set, we will make sure to have the correct questions, the correct number of nodes, and that's what building a decision tree is all about. So whenever you think of decision trees henceforth, think of the 20 question game which we just played right now. So just to summarize this lecture, we learnt about the definition of decision tree. It has a statement and a decision is made. Then we learned that there are two types of decision trees. There is a classification tree and a regression tree. We looked at a simple classification tree where information flows into nodes and then it reaches towards the end. The greater the number of nodes in subsequent layers, the more the depth of the tree is. Finally, we also looked at some terminology. We looked at the root node, we looked at the internal nodes or branches, and we looked at the leaf nodes. We saw a very interesting example to demonstrate how the decision tree is actually very similar indeed to a 20 question game. And finally, I will have a small section on what we will cover in this playlist. In this playlist, broadly, we will be doing three different things. First, we will build an entire classification tree from scratch without any code, so that you will understand the basics such as what is meant by Gini impurity, then what is meant by entropy, how are decision trees exactly optimized, what is the cart algorithm, the hint algorithm, the hunt algorithm, etc. So that's the number one goal. The number two goal is to build a regression tree from scratch. So we'll build a classification tree from scratch and we'll build a regression tree from scratch. In these parts, I'll write down everything in front of you on this whiteboard so that you understand every single thing in detail. Everything will be spelled out. I'll not assume anything. And then finally, we'll go to the last step where we'll implement everything from basics in Python. This is where you will see that why part 1 and part 2 is important. The mistake what many students make is that they directly start from part number 3 here. So they don't understand any concepts which go into really building a decision tree. It's a very fascinating concept and I intend to make it from scratch, just like there are other playlists on this channel such as machine learning teach by doing. There is the neural network from scratch series, machine learning research, explainable AI, data science, data structures and algorithms, etc. So this is an additional playlist, and as always, this will be very high quality material and we'll cover everything right from the basics. So I'll keep on making more and more videos based on these three agenda points, and I'll try to make sure that you get the intuition and then later you are also experienced in the Python coding. So thank you so much everyone, and I look forward to seeing you in the next lecture.